Hello everyone, and welcome to lesson 4.2, which is solving one-step equations using multiplication and division. In the last lesson, we talked about how to solve one-step equations using addition and subtraction. This lesson is not much different. We are still using our opposite operations, and now we're going to look at the second line of our opposite operations. We know that we're supposed to take whatever the problem gives us. We also understand that we are supposed to use opposite operations. So if we see multiplication in these type of problems, we need to solve by using division. If we see division in the problem, we know we need to solve by using multiplication. So that's where we're going to focus today. So again, when we're looking at our steps to solve, all we're going to do is, again, number one, take what the problem gives us. Whatever we see to solve, we're going to do the opposite. And then step number two, we're going to perform that opposite operation on both sides of the equation. As long as we perform them on both sides of the equation, we're keeping the equation balanced and we're treating all parts equally. And that is the ultimate goal because that's what's going to help us solve for our variable. All right. Let's take a look at our examples here. We have 4 examples in the problem to look at. The first one is 9a equals 99. Now, this is something that is not talked about a lot in textbooks or maybe that students miss. And it is, as we move into algebra, how things are written have just changed, right? 9a is really multiplication. And it's kind of difficult sometimes for people to make a jump because what we remember when we're growing up, like if I wanted to multiply a couple things together, maybe I would multiply 2 times 3 and we would use the X symbol. But then later on that becomes 2 dot 3, which also means times. And then now all of a sudden maybe we have parentheses where things are just smushed together. As time has gone on, different things mean multiplication. In our case now, anytime we're dealing with coefficients and variables, or if you'd rather, letters and numbers, anytime you see a number and then a letter right after it, just written back to back, that is automatically multiplication. So, really and truly, if I wanted to write that out, I could say that that's 9 times a is equal to 99. But it's up to us to understand that and know what that means. So, now that we know that 9a means multiplication, and if I wanted to, in the red here, I could just draw a little dot like right between to help show that. If that helps you, by all means, whatever you need. But if we know that 9a is equal to 99. The opposite of multiplication is division. So I'm going to divide by 9 on the left-hand side. I'm going to divide by 9 on the right-hand side. 9 divided by 9 is 1, which is 1a, is equal to 99 divided by 9 is 11. Now, here comes something else that they don't really tell you a lot of times in math books, and that's special kind of unwritten rules when the number 1 is involved. Whenever we are doing division or any time that we're dealing with variables, if there is a 1 in front of a variable, most of the times it will not be written. You just need to understand that if you have a, you have 1a. If you had more than 1a, it would be 2a or 3a or even negative 7a. But if it's just 1, then you will not see the number 1 written. Instead, it will look like this: a equals 11. All right. This step in the middle is unnecessary, but if it helps you get the right answer and if you express it in this format, it doesn't make it wrong. What you need to know is that a lot of times books, quizzes, tests, explanations online will never put 1a in there. They will just go immediately to a. But I will do a little bit of both to help you guys out. So on to number 2. Number 2, we have 72y equals 8. So again, we're doing the same thing. We know 72y is really 72 times y. So all we have to do is divide both sides by 72. Right? We know that 72 over 72 reduces to 1, and that leaves me with 1y. And now 1y is equal to 8 over 72. Sometimes people try to make more of this than what it is, but in reality, it's just a fraction. Division is fractions. They're the same thing. So once we know that y is equal to 8 over 72, it's really just a matter of reducing. And to reduce, all we have to do, and I'll zoom in here to help you out. To reduce, all we have to do is just find what number can go into both 8 and 72. Well, the answer is 8. I know 8 can go into 8, but I know 8 can go into 72. So 8 divided by 8 is 1, and 72 divided by 8 is 9. So the answer to this final fraction is 1/9, or you could rewrite it as y equals 1 over 9. And just as a FYI, yes, absolutely, every time. If you get a fraction as an answer, that's okay. It's possible. But you also have to reduce it. Giving a fraction that's not reduced is more than likely going to lead you to a wrong answer. So, there's our first 2 problems. Now we're moving on to our second 2 problems. Problem number 3 has a fraction. It looks like the fraction is x over 4 equals 10. But we just mentioned this issue in number 2. X over 4 is really division, right? X over 4 is the same thing as me saying x divided by 4 equals 10. Now, some people could look at the problem I've just written in pink and know how to solve it. But if you have x over 4 written in a fraction, which is typically going to happen, that's the standard way generally to write that. You will not see this new way that I've written in pink. You will see it as it's written in example number 3. Well, how do you handle that? Well, again, take what the problem gives you. If it's x divided by 4 and I know the problem is using division, to solve it, I'm going to do the opposite. I'm going to multiply by 4 on both sides. Doing that, the 4's cancel, leaving me with x on the left, and on the right-hand side, I get 10 times 4, which is 40. And again, no matter what the problem looks like, it's all about what you do. Take what the problem gives you. In the last example, again, things are backwards. We got negatives going around. A lot of times, all of that window dressing just like freaks people out, but we don't have to worry about it. We look at the problem. We have -7 equals y divided by 3. And again, we know that that fraction means division, so y divided by 3. To solve that, since I'm dividing by 3, in the problem, I'm going to multiply by 3 on both sides to solve. The 3's cancel out, leaving me with y on the right-hand side. -7 times 3 is -21. Yes, it's okay to get negative answers, and now we've solved the problem. So, now we have seen several examples of multiplication, using multiplication and division to solve problems, and that should get you through most of the problems, if not all of the problems, in 4.2. We just have to remember that notation here is just as much of the learning process as is how to solve the problem. We've talked about how 9a means 9 times a, how x over 4 is really x divided by 4, and how 1a or 1x or 1y is just the same thing as a, x, or y. So there's a lot to it. And as long as we can learn the notation and learn how to solve the problems, we'll be in good shape. Hopefully this has helped you guys out with section 4.2, but as always, if you have any more questions, please let me know.